animals and see if I thought that animal could evolve. Well, the first thing that we really studied together was this little bug called a bombardier beetle. And this little insect is about a ½ inch long, and it mixes chemicals that explode. So I began to think, okay, now how would that evolve? Let's say if evolution is true, and you're evolving along here, and you don't have a defense mechanism, because that is the defense mechanism of the bug. So if evolution is true, it had to somehow evolve that. So let's say it's coming along here. Well, the first time it evolves the explosion, what does it do to the bug? Boom, you just splattered your bug, okay? So splattered bug pieces don't evolve. So I thought, how could this have happened? Well, it doesn't blow itself up. It has another little factory inside itself that manufactures chemicals. A chemical acts as a catalyst so that when you squirt that chemical in with these other chemicals that are like in neutral, you get your explosion. Well, the first time it manufactured that little chemical, here it goes again, blew itself up again. But it doesn't. Why? Well, because it has like an asbestos-lined firing chamber. And even then it would blow itself up if it didn't have somewhere for the explosion to go. So it has like twin tail tubes. And it can aim these tail tubes all the way up, out the side, out the front. Let's say a spider is coming up toward its side and it doesn't have time to turn around and shoot. It can just take its little gun turret and aim it out there and shoot. The explosion on this little bug, all you hear, if you're listening as a human, you hear this pop. But scientists have now put that explosion in slow motion. And it's like about 1,000 sequential little explosions, but they're so fast, all we hear is one pop. And so you think, well, now, why would that be? Well, that was a curious thing for the scientists that study this little bug. A lot of them at Cornell University, some other places. And what they discovered was that if it was just one big pop, the little bug, if he's shooting like a spider, let's say over here, and he goes room, bang, and shoots it, he's going to pop himself right out of there. It's like lighting a burner on a jet engine. So he's out of there. But as long as it is a sequential explosion with his little legs, he can hang on. How would evolution explain a sequential explosion? This little bug messes with all the theories of evolution. There is no way a slow, gradual process is going to produce this bug. There's no way even the newest theories of evolution, like punctuated equilibria, which means evolution happens very fast. Well, there's no way that will explain this little bug. I began to realize, how could this particular little animal, for instance, evolve? It needed all of its parts. It needed everything there all at once, or you just don't have the animal. A bull giraffe is about 18 feet tall. In order to get blood up that long, skinny neck against gravity, the bull giraffe has to have a powerful pump, and that's his heart. And the heart of a bull giraffe can be as much as 2.5 feet long. Big, powerful pump. Now, as he's going along here, living his life, everything's just fine, but all of a sudden, this 18-foot-tall creature decides, I need a drink of water. So he bends his head down to get a drink of water. Now we have a problem. Because now this powerful pump, instead of pumping against gravity, is pumping with gravity. And so the heart gives a mighty squeeze, and the blood shoots down his neck, hits his brain, and bursts his brain. And so now he just blew his brains out. Okay, so he's dying, and he must be thinking to himself, I need to evolve something here to take care of my problem. When I get a drink of water, I blow my brains out. Of course, we know dead creatures don't evolve. But he doesn't blow his brains out because as he bends his head down, there are like little spigots in his artery that goes up the neck, little valves, and they close. But the last pump is beyond the last valve. And so it's enough to burst the little arterioles in his brain, but it doesn't go into his brain. The last pump kind of goes whoop underneath the brain into like a sponge. And this sponge just gently expands, and he hasn't blown his brains out, and he gets his drink of water, and now he sees a zebra kind of running up from this side, and he just ignores it. But he sees a lion coming up from this side. Oh, the lion wants to eat me. I got to get out of here. Now, how does he know the difference, by the way? Evolutionists can't explain that to us. But the fact is, here comes this lion. He's going to eat the giraffe, and so the giraffe jumps up. He runs about 5 steps, passes out. Not enough oxygen to his brain. While he's there, passed out, the lion is eating him. He must be thinking, I need to evolve something here. I got this problem. I pass out when I get up too fast. But he doesn't, of course. Well, why? Well, because God made him so that when he begins to bring his head up, the little spigots, the little valves in the artery open, The sponge under the brain gently squeezes that last little pump of oxygenated blood up into his brain. There are little valves in the vein that goes down the neck. They close, and by the time he's up and running, everything is fine. His blood pressure is fine, and he does just fine. Well, how would that evolve? He needs all of those parts, all there, all at the same time, all at once, or he's dead. And so I think the giraffe is another example of a designer. He needed a designer to design him just like he.
The bears of North America are large, powerful creatures. Grizzlies can weigh up to 860 pounds, and polar bears over 1,300 pounds and can run up to 30 miles per hour. But they also have an enormous appetite and spend most of their time foraging for food, building fat for hibernation. Here in hibernation, one of creation's unique miracles occur.
The mothers have their baby bears, and they nurse those baby bears for up to 5 months. They never drink a drop of water. Well, where's all that fluid come from to nurse a baby bear for 5 months, sometimes 7 months, when you're not drinking anything? What happens is, the bear is fat when he goes into hibernation. The fat in the bear breaks down. Each gram of fat gives off 1.5 grams of water. And that water goes back into the bear's system, and that's how the mother makes the milk that she feeds the baby. She also doesn't go to the bathroom. And so her extra fluid is recycled. The bear has little factories inside itself that turn that into the proteins that it needs to nourish its body as it's going ahead and feeding its baby. Well, the scientists don't even know how it does that.
Another mystery is how hibernating bears preserve their muscle strength. Bears lose only 20% of their strength during this 5 months of hibernation.
Now, if you put a human in a bed for 5 months, we lose 90% of our muscle strength. Our muscles just deteriorate. Even in a month, they just deteriorate. If a lion was to come after a bear right after he walked out of hibernation, he could fight that lion, and he is strong. So recently, they've done some experiments, and they hook some instruments up to a bear in hibernation, and they've discovered that bears go into violent chills, and they'll tense up their muscles, and now they think maybe it's like isometric exercises, that the bear keeps its strength all through the winter by tensing its muscles. And it's like God built that into the bear so that it could protect itself and take care of itself and protect its young right away as soon as it comes out of hibernation.